So I just picked 2 out of the textbook and picked the even ones since y'all don't have the answers for those. So, in all the examples I did when I did the excess reactant, we had already solved for the limiting reactant. Here, we've got to first find out who's the limiting, who's the excess, then go from there. But this one is a little easier than all the other ones because we start with moles and we're going to end with moles. So we don't ever have to calculate the molar mass. So what we've got to do is we've got to convert moles of FeS to one of these products. Then we got to do the same thing with moles of HCl. It doesn't matter which product you choose to solve for as long as you solve for that same product in both of them. So who do y'all want to solve for? Okay. So we're going to go from moles of FeS to moles of FeCl2. So 0.223 moles of FeS. The only thing I have to do is the mole-to-mole ratio. There's 1 mole of FeS to 1 mole of FeCl2. Okay, so we just get 0.223 moles of FeCl2. So now we're going to do the same thing, but we're going to start with moles of HCl. So 0.652 moles HCl. Again, only step we do is the mole-to-mole ratio. 2 moles of HCl per 1 mole FeCl2. Right, so from that, who is my limiting reactant? FeS, because it produced the smallest amount of product. So FeS is my limiting reactant, and therefore HCl is my excess reactant. Okay, so to find out how much of the excess reactant I need, this time we are going to go moles of our limiting reactant to moles of our excess reactant. Okay, so in other words, FeS to HCl. So start with your 0.223 moles FeS. 1 mole of FeS to 2 moles of HCl. And again, it's just a one step because we started with moles, we're going to end with moles. So I got that 0.446 moles of HCl is needed to completely react with this amount of FeS, right? Okay, so the question is how much is left. So you start with how many moles we were given of HCl, which was 0.652. Subtract how much I'm actually going to use. Here's my final answer. Any questions about that? Mm-hmm.
Wait, why did you use the 0.652 again?
This is what we started with in the problem. Yes.
Can you use like H squared, HG?
Yeah. In this problem, it doesn't matter which product you solved for because they didn't ask you to calculate the theoretical yield of any specific product or the percent yield. Okay, so it was your choice.
So you just still do the same thing just with the other product?
Okay, let's look at one where we do everything. So in this one, we're going to find limiting reactant, theoretical yield, percent yield, and the amount of the excess reactant left over. Okay, so if I had not told, if there was more than one product, and I didn't say what theoretical yield or percent yield you were finding, how would you know who you were solving for?
It's a
Yeah,
relative
exactly.
29 ratio.
Yes. This tells me my what? What is this? Actual yield. So always use your actual yield as the clue as to what product you're interested in, if there were more than one product. Okay. So we've now got to go from magnesium to magnesium oxide, then oxygen to magnesium oxide to determine limiting reactant and theoretical yield. So let's do it. 10.1 grams of magnesium. Three grams of magnesium and 1 mole. Okay, then for 2 moles of magnesium, I produce 2 moles of magnesium oxide. You could always just stop at moles and then convert the smallest mole to grams. But sometimes I don't do that and I just convert it to grams in both steps. Only one extra step. What is your personal preference? Okay, for that step, I got 16.75 grams. Somebody else gets that? Okay, great. Alright, then I'm going to do the same thing with the oxygen. Molar ratio. And then when I converted grams of oxygen to grams of magnesium oxide, I got 26.45 grams. So who's my limiting reactant? Magnesium. And so therefore this is my theoretical yield. Magnesium equals limiting reactant. Alright, so now let's calculate our percent yield. Percent yield is actual over theoretical times 100. You're always given your actual. You always solve for your theoretical. So for percent yield, I got 71%. All right, and the last step, we've got to find out how much of the excess reactant we're actually going to use. You can, of course, start with grams of your limiting reactant and go to grams of excess, or you could start with your theoretical yield and go to grams of oxygen. It's up to you. If you want to keep things simple, we'll just go grams of limiting to grams of excess. How about that? Let's start with 10.1 grams of magnesium. Convert that to grams of O2. I get 6.65 grams. And so 10.5 grams, that's how much I was given in the problem. Minus 6.56. So the last part of the question is 3.85 grams of oxygen remains. Questions about any part of that? Yes.
So for when you convert it to moles, why did we divide by 24.3 instead of 40 or 48.6? Because of NG2.
You don't have to do that because the mole ratio takes care of that. Yeah. So right here, I'm only talking about magnesium,
Okay.
not 2 of them.
Got
Okay, so this is really everything we did in chapter 7, except we didn't balance the equation before we started because it was already balanced. Yes, ma'am. More than likely, yes, but I'll always tell you too in the problem, like, hint, balance the equation first. And then on other problems, I'll just go ahead and give it to you balanced. I did post that balancing practice, but I don't think I've posted the answers yet. I have that on my list of things to do for today. Okay, so do y'all have any questions about chapter 7 before we look at chapter 5?
You look at balancing equation, like a balancing equation.
You want me to do one?
Yeah.
Okay. Let's find a good one.
What were you doing right there to get that 6.65? Like I see the between the magnesium and oxygen, but like.
So I just started with the amount of magnesium that we were given in the problem because we determined that it was our limiting reactant. So I want to know how much then of oxygen I need to completely react with that amount.
And then what you have left there.
Yeah. So I only need 6.65 grams, but I'm starting with 10.5, so I have 3.85 left. Yeah. I feel like somebody's burning a candle that smells like a Christmas tree. Okay. Let's balance this equation. Alright, so how I do it is I make me a little chart of all the elements that I'm going to encounter. If I have a polyatomic ion and it remains unchanged from reactant to product side, just balance it as one thing. Like it's NO3 here, it's NO3 here. There's just a different number of them. Alright, so I got 2 sodium, 1 sulfur, 1 copper, 2 nitrates. 1, 1, 1, 1. Oh, this one's easy. What do I need to do? That takes care of everything. Yes.
And we need to like write out. Will you give it to us like work when we don't have to like.
That's what I was about to ask. Is if we get it in Word and have to write it?
No, I will not give it to you in words and you have to actually write the equation. The only thing I might give you in words is to draw a Lewis structure. I might say draw the sulfate ion. So you would have to know that sulfate is SO4 2 minus. That's it. Yes, ma'am.
I have a question on one of the sheets of the practice problems that you gave.
Yes.
It's number 6. I think they're both the same, but it's the one with like parts A, B, and C.
Okay, I probably don't have that.
I can give you
Is it on chapter 7 practice problem? Consider the reaction MnO2. Okay.
I'm extremely confused by part C.
Okay, calculate the moles of excess remaining at the end. Okay, so
Is that just what we did, like what you and Boston about why we,
right.
that's just the last part of the one.
Yeah. That is it. Yes, ma'am. Yes. So the only reactions that I told y'all to be familiar with in this chapter is a combustion reaction. So, in a combustion reaction, you always have something that's reacting with O2 that's forming CO2 and water. This something has carbon and hydrogen, or carbon, hydrogen, and oxygen. So in this example, it says how many grams of oxygen are necessary to completely react with 22.8 grams of methane, and it tells you that that is CH4 in a combustion reaction. So I know that when it says combustion reaction, this is what that means. All of this. I just had to plug in this part. But this equation's not balanced. So, let me show you again how I balance combustion reactions. First thing I do, I take whatever subscript the hydrogen has, and I put it in front of water. So I have 4 hydrogens, I'm going to put a 4 right here. Okay, then I come back over here and balance out my hydrogens. Every time it should be a 2 because it's always water in there. Now balance your carbon. I have 2 here, I need 2 here.
And then you just balance off.
Yeah.
There's 2.
How many do we have? We got 4 here, 4 there, 8. What I need to put right here. So we can actually reduce this down since they're all a multiple of 2. It would be 1, 2, 1, 2. Now we can actually do the problem. So it asked us to find how many grams of oxygen is needed to react with 22.8 grams of methane, which is CH4. So let's convert that to moles. Then use the mole to mole ratio. I can do 1 mole of CH4 to 2 moles of O2. mole O2's molar mass would be 32 grams. At 90.96 grams, we're doing the correct number of sig fig. Be 91.
That's how much oxygen is needed to react with the 22.8 grams of methane.
Correct.
And you said combustion reactions are always methane and oxygen yielding carbon dioxide and water, right?
This will vary, but this stays the same.
I got you.
Alright, let's do a few Lewis structures from chapter 5. So this is how most of your Lewis structures will be asked on your test. I'll ask you to draw the Lewis structure, determine the molecular geometry, and then tell me if it's polar or non-polar. So, do some. I'm gonna give y'all 4 minutes to see what y'all can do here, and I'll do them. Alright, I'm gonna go through and I'm just gonna draw the Lewis structure real quick, and then together we'll look at geometry and polarity. Alright, so here are my 4 Lewis structures. Ooh. Before I go any further, are there any questions about how I drew those? Any of you miss SO2, I might scream. I've done this one like 3 times now. B? Okay.
Is it because of the geometry? Is that why you like it?
Yeah. So you could have drawn it like any way you wanted to, as long as everything was connected to carbon. Alright, so what is my molecular geometry for A? Yes, trigonal pyramidal. It's not planar because of that lone pair. So is it polar, non-polar? Polar, yes.
Because of the long hair.
It is because of the lone pair, and if you have equivalent bonds, which we do, by equivalent I mean they're all hydrogen to nitrogen single bonds, and you have trigonal pyramidal geometry, it's always polar. What is my geometry for B? Has something to do with trigonal, because there's 3 bonding groups. Is it planar or pyramidal? Planar. It's planar because there are no lone pairs on my central atom. So all 3 of those electron groups are in the plane of the paper. Alright.
So the pyramidal and planar are based on the lone pairs on the central atom.
The polarity might be tricky. Do you think it's polar or non-polar? It's polar. The reason it is polar is because all 3 of these bonds are not equivalent. And because of the electronegativity difference between carbon and oxygen, I have a negative region here, a positive region here. If all 3 of my bonds would have been the same, it would have been non-polar.
Because of the different oxygen, then it makes it polar.
Right. Okay, what's my geometry here? Yep. Polar, non-polar? Non, because it's symmetrical. So even though these are all polar bonds, because it's in a tetrahedral geometry, they cancel each other and it is non-polar. And lastly, what's my geometry here? Yep, polar, non-polar. Yep, polar. Yes.
Are we gonna have any weird ones where it's like seesaw?
No, if you have seesaw, if you have anything other than the ones I put on the board that one day, it'll be bonus. The only other thing I could have asked here was for you to do the formal charge. I didn't do that. Okay. Also, be sure to look at resonance structures. I didn't get a chance to do that either. And know your incomplete octets and your expanded octets. I haven't made the test. I'll do it this afternoon. I'll send y'all the format of it along with the spreadsheet that tells you when you're taking your test. It's the same spreadsheet as exam 2, so if you remember when you came to take that, I'll see you then. Don't forget, if you want to pick up any of this, you may, or if you didn't get your exam 2, I have them. Have a good weekend.